Okay, so this is the second graph for, or the second video for the example. I'm sorry that I ran out of space on the last one. I wasn't paying attention to the time, and then it started flashing at me. So, all right, so here we go. Let's record. Let's do our last example for sine and cosine. So we're going to take all our x values, and we're going to divide them by 3. So the first one is 0 divided by 3. That's pretty straightforward. That's just 0. Pi over 2 divided by 3 is going to become pi over 6. Because remember, dividing by 3 is the same as multiplying by 1/3. Pi divided by 3 is pi over 3. 3 pi over 2 divided by 3 is going to become 3 pi over 6. And just like the last one, we do not want to reduce our fractions, because this is going to let us see a pattern that's happening. It's also going to help us with finding our common denominator and everything else when we go to want to get our scale for our graph. And then 2 pi divided by 3 becomes 2 pi over 3. So far it's kind of looking like our last graph, our x values, but that's going to change. Y values. Well, our a is -1, so we're going to go 0 times -1. Well, that's just -1. 1 times -1. What am I doing? I keep doing that with 0. 0 times -1 is 0. 1 times -1, -1. 0 times -1, that is 0. -1 times -1 is +1. And then 0 times -1 is back to 0. So all that's happened is these y values have kind of just flip-flopped a little bit. They've just done the reverse. And remember, all that negative does is that's a reflection. So we have a reflection this time. So it's going to flip our graph over. Now let's do our next set of points. And again, I'm going to give myself lots of room for my x values. Because I am going to be working with some fractions here. So I'm going to be subtracting pi over 6 this time. So for the first one, 0 minus pi over 6. That's just negative pi over 6. Pi over 6 minus pi over 6. That's a 0. Pi over 3 minus pi over 6. Common denominator is going to be 6, so that becomes 2 pi over 6 minus pi over 6. And that's just pi over 6. 3 pi over 6 minus a pi over 6 becomes 2 pi over 6. And again, you don't need to reduce, because as you look at our x values, we're going -1 over 6, 0, 1 over 6, 2 over 6. It's going up by pi over 6 this time again. That's going to make things easier. 2 pi over 3 minus pi over 6. That's going to give me 4 pi over 6 minus pi over 6. And that's 3 pi over 6. So that's going to help us with our scaling. That's all it helps us with, by not reducing. If you want to reduce, you can. That's up to you, but you better hope you get your scale right on your graph. Okay, now let's do our y values. So again, this was x divided by b plus c. Here it's a times y plus d. So that's going to be 0 minus 1, and that is -1. That's the first one. -1 minus -1, or minus 1, is -2. 0 minus 1 is negative 1. 1 minus 1 is 0. And then 0 minus 1, negative 1. Okay, let's scale it. Let's graph this. As I make my axes here. So we're going to count by pi over 6, so negative pi over 6 goes right here. 0 pi over 6. Can't probably fit the 2 pi over 6 in there. 3 pi over 6. 4 pi over 6. 5 pi over 6. And I think we have enough. Now, so we could do, on our y values, we can go negative 1. Actually, you know what? I'm going to make it a little bit bigger so we can see it negative 1 and then negative 2. So I'm going to go every other one for that one. Okay, so let's plot our points. Negative pi over 6, I am at negative 1. So I'm going to change the color of this, by the way, so that we can see it here. And then I have 0, negative 2. Hold on here, I put the negative 1 right there. 0, negative 2. Pi over 6, negative 1. 2 pi over 6, 0. And 3 pi over 6, back to negative 1. Okay, so there's my graph. So it looks like a sine graph. It's just upside down. It's been flipped over. So let's do all of our information. Amplitude, again, that's our a value. It's the absolute value of a. So the negative only reflects it. But the a is actually 1. So our amplitude is 1. Our period, remember, our b is our 2 pi divided by b. In this case it's 3, so it's 2 pi over 3. Our phase shift is our c value, and it's a negative pi over 6, so it means it moves it to the left, pi over 6. Our vertical shift is negative 1, so it shifts it down 1. Okay, so now we have our domain. Our domain, again, is all real numbers. Our range. Our lowest y value is negative 2. Our highest is 0. Now, before we didn't do x-intercepts because we would have to use trig equations. Well, we can see that it only crosses the x-axis once, and it's going to do it only once every period. So we can take that x value for our x-intercept. We can actually write it out this time, and this is how it's going to look. It's that value. In this case, it is, where is it? The pi over 3, because it's 2 pi over 6. It's going to be at pi over 3, plus or minus our period, which is also 2 pi over 3. Excuse me here, comma 0. And we'll get into more about what this is next time, or next unit, I believe. But just that's what it would look like, because it is happening every time we hit back at pi over 3 in our period. The n just means the number of rotations we're going around. It's going to hit every single one of them. Y-intercept, our y-intercept, we can actually just look at the graph here. Makes it easy. That's at 0, negative 2. Again, there are no asymptotes. Alright, so this is the last graph for section 4.5. Alright, we will continue on with the next one.